Hello students, we will be doing chapter 3, which is Gauss theorem. Okay, Gauss theorem. Some writes Gauss law, some says it's Gauss theorem. Okay, in ABC text book, this might be chapter number 4, but here I will be doing it as chapter number 3. Okay, now first of all, before doing what exactly the Gauss law is, Gauss theorem or Gauss law, okay, that's sometimes both can be used. Okay, very important points only I'm going to highlight it here. Those points you have to keep into your mind. Okay, first of all, we will start up with area vector. See, in physics, area is a vector quantity. It is not a scalar quantity. Okay, now area also we can have two-dimensional 2D and we can have three-dimensional, right? 2D we call it open surface. Okay, open surface, and three-dimensional, these are closed surface. So we are going to discuss them individually. Okay, now what is area vector, and as it is a vector, what should be the direction of it? Okay, let me consider one area. Let's say simple area lying in the xy plane. Okay, let's say a square, let's say, okay, of side A and A. Okay, now the magnitude of the area, how much the magnitude of the area, area of a square is what? A square, right? Now what is the direction of the area? The area vector should be perpendicular to this plane. Okay, perpendicular to this plane means what? The z-axis, right? It can be either the z-axis or it can be the down z-axis, that is z dash axis, right? So that is basically the area vector. So what is, in this case, z-axis we denote as unit vector of k. So if I write it as area vector, then it will be k cap. It can be minus k cap also, it can be k cap also, don't bother about that. Okay, so what is the direction of the area vector? Area vector is perpendicular to the area of the in which the plane in which it is lying. Understood? Okay, so normal. Okay, directed, so I'm writing for it to be much clear, directed normally. Okay, directed normally. Okay, area is a vector. The direction is what? Normal. To where? To the plane of it. Okay, now coming about the closed surface. Okay, 3D. Now let's say 3D surface. 3D surface we called it as a closed surface. Okay, closed surface. Okay, now in a closed surface also the concept will be the same. 3D, let's say here is a sphere. Okay, here is a sphere. Okay, now what is the when is a closed surface means what? Surface area, right? And what is the direction? Now if it is a sphere, what is the formula for the area of it? It is 4 pi r square, where r is the radius of it. Now if it is an area vector, okay, if it is the area vector, then what would be the direction of the area vector? Now area vector should be 90 degree to the surface. Now if it is a sphere, the 90 degree, all this one, okay, 90 degree to the surface. Okay, 90 90 degree to the surface. I hope we can understand it. Okay, another example I will take. So what is the direction of the area vector? Direction of the area vector is what? It is normal to the surface. Okay, fine. Now let's take one more. Let's take another one for the 3D surface. Okay, 3D means what? Closed surface. Okay, let's say here is a cube. Okay, here is a cube. Let me make a cube. Will I be able to make a good one or not a good one? Let's see. Okay, and okay, let's say this is a cube. Okay, now how many surface area it has? One this, another this, another this, another this, another the front, and another is the back part, right? So how many surfaces it has? It has 6 faces, right? Okay, now what is the area vector? What is the concept? It has 6 faces means what? It will have area. For this, the area for this one, let me mark it with this. For this phase 1, let me call phase 2, let me call phase 3, phase 4, phase 5, and phase 6, right? Area vector for 1 should be what? Perpendicular to it. So what is the direction of the area vector? This is the direction of the area vector, 90 degree to the surface. Okay, now 2, always remember area vector should be 90 degree to it. It can go inside, it can go outside. Always take for the closed surface, for 3D surface, remember, always take the outside one, not the inside one. What I meant, again, we have what to say, area 1, right? Now this face the same. Now the area can be perpendicular to it, so it can be either this side, either this side, right? Isn't it? Right? 90 degree both, but always take the outward one. I will tell you the reason behind it. Okay, always take, not the inward one. Okay, similarly for phase 2, what would be the area vector? Outward area vector. Okay, phase 3, what would be the area vector? Perpendicular to it, area vector, not the inside one. Okay, phase 4, what? Outward area vector. Okay, 5, I can't show it, area vector. 6, what? Perpendicular area vector. So when it is a 3D surface, that is 3D is a closed surface, always take the area vector which is normal, pointing outside. Okay, outside. For a plane, for 2-dimensional, it can be normal, it can be outward also, it can be inward also. That depends upon the situation. Okay, clear? Shall I take another closed surface? Okay, because closed surface, suppose I have a cylinder. Okay, this is also a 3-dimensional surface. Okay, now what would be the direction of the area vector? Again, area vector, see, there are cap area, and there is lateral area, right? Right? For this cap area, what is the area vector? Outward, right? This is the area vector, right? For this cap area also, what is the area vector? This is the one. What about this? 90 degree to the surface, right? 90 degree to the surface will be what? Does it look 90 degree? Hold on, huh? Area vector, right? Similarly here also area vector. So what we have seen, in the case of cylinder, the area vectors are pointing differently for the cap and for the lateral surface, right? So fine, I hope we can understand it, right? So what we have learned, that area vector, let me summarize it. Area vector, area is a vector quantity. Area can be two-dimensional or three-dimensional. If it is three-dimensional, we call it a closed surface. As it is a vector, what is the direction of the area? Perpendicular to the surface, right? Then for closed surface, we have to take that perpendicular component which is pointing outward. Okay, clear? Okay, now if we are clear about the concept of the area, then we can go to the concept of the flux. Okay, and now as we are talking about electric, so the concept, our next topic is electric flux. Okay, it is denoted by a symbol of phi. How we pronounce this one? We pronounce this one as phi. Phi. Okay, now what it is? Okay, to explain this, let me consider one surface. Okay, let me consider one open surface. As we are talking about the electric flux, so we have to consider about the electric field. Let's say this surface is placed in a uniform electric field. Now you have seen that the parallel equidistance lines, what does it means? Uniform electric field, right? Uniform field lines are parallel. Now the electric flux is defined, you will see in the notes, the electric flux is defined as the total number of field lines passing through the area, normally. Okay, passing through the area normally. So what it is? It is the total number of field lines. Okay, total number of field lines. How many field lines is crossing the area perpendicularly? All right. Now, in this case, you may say, in this case, how many field lines is crossing this area normally, because the field is going along x-axis, y, the plane is it in the yz plane. Okay, so how many? All of them are 90 degree, right? All of them are 90 degree. We'll see it. Now you may call it 4. Though the definition looked this way, but we cannot call it 4. Okay, because field lines is a matter of our choice. For this electric field, one student may have made 4 field lines, another student may make 5 field lines, another student may make 6 field lines. So though the definition, the total number of field lines, but this way of counting is wrong. Okay, so this is not correct. Okay, so what we need to understand, this flux, okay, this flux phi is directly proportional to what? Electric field. More the electric field, more the field lines will cross the surface. Yes or no? Does it make the sense? Okay, another, higher the area, okay, higher the area, higher will be the flux, right? Okay, you can imagine this way. Pipe, from the pipe water is coming out. All right, bigger the pipe, bigger the cross section of the pipe, more water will come out, right? higher the force, more water will come out, right? So the quantity of water which is coming out from the pipe depends upon what? The water force and the cross-sectional area. Similarly, in this case, the flux, total number of field lines, right? How many fields will pass? Stronger the field, bigger the area, right or not? Right? So, if we combine this two, what it will be? Now see, flux, it is a scalar quantity. But electric field is what? Is a vector quantity. Area is also a vector quantity, right? Two vectors multiplied giving a scalar quantity, then what type of product it need to get? It need to have the scalar product. So this will be what? This will be E dot E. Okay, see, we have two types of product. One is dot product, another is cross product. Cross product will come when two vectors multiplied, the answer is also a vector. But in this case, phi is a scalar quantity. Okay, so as it is a scalar quantity, but it is multiplied of two vector, what type of thing we need to choose? We have to choose the dot product, which is a scalar product. Now this is equal to the constant is 1, so this is, in this case, this is the definition of the flux in case of, in this case, what we take in case of uniform field. Okay, so what is flux? Flux is the totality of electric field passing through that area normally. Okay, now another thing also, when it is dot, what should comes? Dot will come what? Dot will cos theta, right? And what is the theta is? Theta is what? It is the angle between, what? E and A. Understood? This is for the uniform field. Again, I'm repeating. Okay, so EA cos theta. If the field is non-uniform, okay, if the field is non-uniform, then the flux can be written as, okay, the flux can be written as integration, small addition, this is E dot dA or E dot ds. Okay, so this is for what? This is for non-uniform field. Okay, mostly we are not going to consider it, however you need to know it. Okay, in general, in all our consideration, we consider the field to be uniform. However, if the field is not uniform, then the flux is given by the integration of this, and this holds always true. Okay, if the field is uniform everywhere, okay, like in this case, then it is the field is uniform over the whole area, right? So this ds will turn out to be A. Okay, so both carries the same meaning. All right, okay, so remember it. What is a flux? It is the totality of the electric field through that area normally. Okay, clear? Now what about the unit? This is the definition. Unit will be in SI will be what? Electric field is Newton per coulomb and area is what? Meter square, right? Newton meter square per coulomb. Okay, so this is what? This is the unit. Okay, students. So now we are going to, based on this, we are going to do some small numericals. Okay, like suppose, let us take a simple one. Okay, the same question, let me do with it. Okay, x and y, square a and a. Okay, then let's say it is kept in a uniform electric field. Okay, it is kept in a uniform electric field, and the electric field is along the x-axis. Okay, fine. All right, it is kept in a uniform electric field, and the question is phi equal to how much? Okay, then electric field is uniform. Okay, then what is the area vector? Area vector is what? A square. What is the direction? Area vector. Area vector should be normal, right? Normal is what? K vector, right? Then electric field is directed along where? X-axis, right? Electric field is directed along x-axis. Then this is what? X-axis is given by I cap, right? Now what is the flux? Flux is equal to E dot A, right? E dot A. Then this is equal to what? A square K dot E I cap, right? Now what is the angle between K and I? A square E. K and I is what? Unit vector. Magnitude of K is 1, I is 1. Cos of how much? What is the angle between them? The angle between z-axis and x-axis is 90 degree. So what is the flux? The flux through it is 0. Okay, so that in this case you may see, though the electric field is passing this area, but the electric field and the area vector is normal. Okay, all right, the area vector is normal to it. So the total flux is how much? It is 0. Okay, now let me take another case. Okay, simple case. I'll choose it. Let's see this way. Let's say this is in the YZ plane. Okay, uniform field again. I'll take this. Let's say it is in the uniform field. Okay, electric field is uniform. Let's say the area is this one. All right, now what is the flux? Flux is what? E dot A, right? Fine. Okay, now what is the angle between E and A? Can you see? Electric field is in the direction of the x-axis, right? Okay, then what is the direction of the area vector also? Area vector is also directed along this direction. Yes or no? Right? Because it has to be normal. I think it's quite evident from the figure. Or if not, I am also not quite satisfied. Let me make it. This is the case. Electric field goes this way. Now what is the direction of the area vector? First of all, what is the direction of the area vector? Area vector should be along here, right? And what is the direction of the electric field? Aren't they same directed? Yes. So what is the flux? The flux is what? E dot A, right? Now if it is E dot A, then what? What is the angle? Dot means what? Cos, right? What is the angle between E and A? This is 0 degrees. So what is the flux? EA. So it's not only electric field and area. How the electric field is, that will determine the flux. Okay, then let me take another one. Suppose here is a ring. Okay, 2 dimension. Okay, then let's say the electric field is directed this way, though parallel, but the electric field is let's say the electric field is directed 30 degree. Okay, this is the direction of electric field. Okay, then what is the direction of the area vector? Can you see? the direction of area vector is across here, perpendicular to it. Okay, right? This is a ring. The ring is in the, let's say, xy plane, and the area vector should be in the, in where area vector should be in the z plane, right? Now what would be the flux then? Flux is what? The flux is what? This is E dot A, right? Now what is the angle between electric field and the area? Isn't it 60 degree? Yes, right? Then this will be what? EA cos of 60 degree. All right, so this way I hope you know how to take the flux, how to find the flux. So E and A you need to know, but you have to take the direction of the electric field. Okay, now let me go to the closed surface. Okay, okay, one, two I will do, the rest you do the previous one. Okay, 1 and 2 surface, this 2 only I am considering. Okay, this is a three-dimensional case, so let me specify this as x-axis, another one as y-axis, and another one as the z-axis. Okay, all right, we can see it, right? Let's say the electric field is directed along the x-axis. Let's say electric field is across x-axis. Okay, for x-axis we have the unit vector I cap, for y-axis we have the unit vector j cap, and for the z-axis we have the unit vector k cap. I hope you remember it. Okay, then the uniform electric field, how well it's directed along x-axis, so what can I do? Okay, uniform electric field, okay, it's uniform electric field. Okay, fine, another this. Okay, so this is uniform electric field. Okay, 1 flux through 1, how much? Can you say? What is the direction of area vector? Area vector should also direct outward, right or not? Okay, so this is what? E dot area vector. What is the angle? The angle here is 0, so what it is? EA cos of 0 degree. Cos 0 degree is 1. Okay, now come about 2. That's the same thing will hold. Now what is the direction of the area vector? What I said, the area vector you should take directed outward. So what is the direction of area vector? This is the direction. Okay, in this case it was outward. In this case, which one is outward? This. And what is the direction of electric field? Opposite to it. So what it need to be? It have to be EA cos of 180 degree, right or not? Yes, let me call this as phase 3. Okay, now for phase 3, what should be the flux? Okay, what is the direction of area vector? This electric field is directed along where? 90 degree. So what it is? E dot A, and what is the angle in this case? It is cos of 90 degree, right? So what it is? It's 0. Okay, I hope you have understood it. Thank you.